Now, so elastic deformation means the losses will occur because of the change in the dimension of the member. Say, let us say this is a initial concrete member before cutting the tendon. So this is before cutting the tendon. Okay. So what happens after the cutting of tendon? So what happens? Now this tendon has been cut. So what happened? Because of this pre-stressing force, this force trying to compress the member, because it is trying to compress this member, right? So stretch చేసాం వదిలేసాం, ఇప్పుడు ఏమవుతుంది, ఫోర్సెస్ అన్ని టువర్డ్స్ ద సెంటర్ యాక్ట్ అవుతా ఉంటాయి. ఈ ఫోర్స్ ఇలా యాక్ట్ అవుతాయి, ఈ ఫోర్స్ ఇలా యాక్ట్ అవుతుంది. Because of this force, counteracting force, what happens, this member tries to compress. So because of this member will reduce its size to some distance, maybe up to here. Little bit it reduces, little bit it shortens. This member little bit it shortens. So because of this, what happens, if the member, if the member is shortening means what, the steel, the tendon will also shortens, right? మెంబర్ సైజ్ తక్కువ అవుతుంది, మెంబర్ దగ్గరగా అవుతుంది, కంప్రెస్ అవుతుంది. అంటే ఏందమ్మా, స్టీల్ కూడా దాని స్టీల్ కూడా చిన్నగా అవుతుంది కదా, స్టీల్ కూడా రెడ్యూస్ అవుతుంది కదా, సైజ్ రెడ్యూస్ అవుతుంది కదా. సో బికాస్ ఆఫ్ దిస్ రిడక్షన్ ద లాస్ విల్ అక్కర్స్. ఓకే, దిస్ ఈస్ ఎలాస్టిక్ షార్టనింగ్. ఓకే, సో దిస్ ఎలాస్టిక్ షార్టనింగ్ విల్ డిపెండ్స్ ఆన్ depends on modulus of elasticity. So modulus of elasticity with, you will denote with E, right? So it depends on modulus of elasticity and the initial friction, the initial pre-stress that have been transmitted. So that have transferred. So it depends on elastic modulus of elasticity of concrete and steel and the pre-stress that have transferred to the member. Okay. Let us say if Fc equal to pre-stress in concrete and Es equal to modulus of elasticity of steel, and coming to Ec equal to modulus of elasticity of concrete. Modular ratio alpha E will equal to Es divided by Ec. Modulus of elasticity of steel divided by modulus of elasticity of concrete. So this is alpha E, modular ratio. Now strain in concrete. Strain in concrete at the pre-stress transmitted to the concrete is equal to divide stress, pre-stress in the steel concrete divided by Young's modulus of the concrete, you will get strain. So what is E? So E is stress divided by strain. Young's modulus is stress divided by strain. So if you want to get strain, so I'm taking strain this side and E this side. So you will get this. Okay, stress divided by Young's modulus of concrete. Modulus of elasticity of concrete. Okay. Now, stress in steel. Stress in steel corresponding to the strain. ఈ strain దగ్గర stress ఎంత ఉంది? So if I take strain this side, it will multiply with E. Okay, so FC by EC, this is strain multiplied by Young's modulus of steel. So you will get stress in steel. So now here this, now if I separate this will be like this, right? EC into ES divided by EC. Okay, now ES and EC is modular ratio. ES by EC is modular ratio, that is alpha E. Now the loss of stress in steel equal to stress in concrete into alpha E. So alpha E is this only. Young's modular ratio. Okay, so basically you will use this formula. Only you will use this formula to calculate the loss due to elastic shortening. Okay, so all this I have told you because just for your understanding purpose. ఈ alpha E ఎలా వచ్చింది, this FC ఎలా వచ్చింది అని కనుక్కోవడానికే చెప్పాను. That's it. Okay, let us see one problem.